Our first section is just a review of the order of operations. Remember PEMDAS, where you're going to do your parentheses or grouping symbols, powers, exponents, multiplication or division from left to right, and then addition or subtraction from left to right. So we're going to run through a few problems of working with the order of operations. At this point, we're going to try not to just plug it in a calculator, although the calculator is a very helpful tool, and as we work through this term, we'll get comfortable using all the different keys on the calculator. But when I do the order of operations, one of the grouping symbols that's sort of hidden is the fraction bar. Whenever I see a fraction bar, it should have parentheses on the top and on the bottom, meaning I have to simplify the top and the bottom first before I can do the division, because the fraction bar means division. So in this top problem, I'll do my multiplication first, 1 plus 6 minus 4 all over 3, and then I'll do addition or subtraction from left to right. 1 plus 6 is 7, minus 4 is 3. 3 over 3 means 3 divided by 3, and my final answer there is 1. When I have parentheses within parentheses, always go for the innermost first. So I'm going to start with this innermost. I'm going to do 15 divided by 5, which is 3. I bring everything else down, and then continue to simplify within. 3 minus 2 is 1. Once I've completed everything inside of that parentheses, I can drop it. Work on that outer parenthesis now. 1 minus 1 is 0. 2 minus 0 is 2. Here I have another fraction bar where I have parentheses on top, but remember, there are invisible parentheses, grouping symbols on that one that we have to keep in mind. So I'm going to work with the innermost again. 4 times 2 over 4. Again, I'm going to assume there's a parenthesis up there. 4 times 2 is 8 over 4. Remember, that means divide. 8 divided by 4 is 2. Moving on, we've got a problem with power on it. Here's an example of brackets. Sometimes we even see braces in there. Instead of doing multiple parentheses like they did in this problem, they'll use the brackets instead. It just basically means it's another set of parentheses, and when I work through this, I'm going to do the innermost first. Well, there's nothing I can do inside of there, but I can raise that to the 4th power. So this is 3 minus 6, parenthesis or bracket, negative 2 raised to the 4th power, negative 2 times negative 2 times negative 2 times negative 2. Will end up being 16 minus 3. Then continue working down. I have to do that multiplication. Even though this screams at me like an easier part of the problem, 3 minus 6 is easier than 6 minus 13, I still have to do the multiplication first. So I end up with 78. 6 times 13, 3 minus 78, negative 75. If I'm subtracting more than what I started with, I end up with a negative value. Again, kind of the same thing on each of these, just working through, doing each of the steps. Sometimes you can do multiple steps at once if it doesn't affect the problem, but just continue to work your way through until you get completely simplified, again, following the order of operations. In the parentheses, then I had my choice of multiplication. I had 2 of them to choose from. I do it from left to right, so I'm going to do this first multiplication, 6 times 2 first, and keep bringing it down. And the next one, 4 times 18 over, I'll do the grouping symbol on the bottom. Now I have multiplication division from left to right, so I'm going to do 4, well, I can, because this is a grouping symbol on it, that division, this would be 4 times 6 times 2. Then I do that multiplication, 24 times 2, and 48. The rest of them are pretty much the same. If you have any questions, give them a try, but pause the video and see how you do. If you have any questions on them, you can just send me an email and let me know. You should get 2 for number 7, 11 for number 8, and 2 for number 9. Again, just double check your work. On the other side, we went through practice solving equations. We did a little bit of that at the beginning of class, just one-step equations. These are multi-step equations. Basic thing to remember is that you're going to be doing the order of operations backwards to get through the solving. You're undoing the things that you would have done in the order of operations, so you're going to work through them backwards. Here, in the order of operations, the last thing I would do is add or subtract, and so that's the first thing I'm going to do when I work backwards is undo the subtraction by doing the opposite operation. Oops. Gotta add that. And then when we cram these together, it means multiplication. Opposite of multiplication is division. I just show it with that bar. If you want to use the divide symbol, you can do that as well. And our final problem is m equals 4. If it wants me to check the answers, I just plug it back in there. Is 6 times 4 minus 8 equal to 16? Well, 6 times 4 is 24 minus 8. 24 minus 8 is 16. My goal is to have that be the same on each side. That's how a check works. When I get it to be the same on each side, I know I've done it correctly. Again, I'm going to work through reverse. I would do addition or subtraction last, so here I'm going to work through that backwards first. A common mistake I see people make here is they see 2 minus 3 or negative 2 minus 3 and they think that's negative 1 or 1 because the difference between 3 and 2 is 3, but this is negative 2 minus 3. It's like negative 2 minus 3 is negative 2 plus negative 3, so that's actually negative 5. Be careful on that, and if you struggle with the rules of positive and negative numbers adding and subtracting, just try to, or just take advantage of using your calculator. If you plugged in negative 2 minus 3, you'd get the same answer there. Opposite of division is multiplication, so I'll multiply that negative 3 out. It's multiplying exactly what I divided by. It's not multiplying the opposite. It's multiplying exactly what I divided by. That's a negative 3 down there, so I'll multiply by a negative 3. K is 15 when I'm done. If I'm going to do a check, I put 15 divided by negative 3 plus 3, and I want to show that equals negative 2. 15 divided by negative 3 is negative 5. And negative 5 plus 3 is negative 2. So as long as the answers match, my check worked out. There are going to be some odd things that happen occasionally when you work with these. Sometimes answers that don't work out perfectly, and that's okay. And sometimes things are going to be a little unclear here. This 6 is the thing that I want to get rid of first. And there's a minus after it, but in front of it, if I don't see a sign, I assume it's a positive. So this is a positive 6. Technically, I'm adding 6. I could rewrite this as negative 8x plus 6 equals 22. Because the 6 would be added, to get rid of it, I'm going to subtract it. So negative 8x equals 22 minus 6 is 16. Divide by the negative 8, and x is negative 2. Again, just going through the steps in reverse order. What if I see a fraction in the problem? Well, I'm still going to follow the same rules. I'll get rid of that addition. And then I'm going to divide by this fraction. The fraction's connected to this x, so it's being multiplied. I'm going to divide by the fraction. We don't divide by fractions, though. We actually flip and multiply them. So if I say I'm going to divide by 2/3, I'm actually going to multiply by 3/2. So that's how fractions work in division. You don't divide by a fraction, you flip and multiply. So I'll multiply those two together. Put the negative 15 over 1, and then I can multiply the top times the top and the bottom times the bottom. If it doesn't reduce nicely, I just leave it as an improper fraction, and that's fine. I can't take anything out of the top and the bottom, and 2 doesn't go into 45 evenly, so you can just leave it as that improper fraction. Lastly, here's the other kind of funny thing that's going to happen, or that's going to look different than maybe any of the other equations that you see, and that one is I have a fraction bar here that is blocking the addition, and so normally I would undo the addition first, but it's blocked by this division of 2, so I have to undo that 2 off the bottom first. It's like, again, I'm doing I'm going to save the grouping symbol work on top for last, because that's the order of operations backwards. So I'll get rid of that division to open up that negative 5y plus 8, and then I'll solve as normal. Subtract the 8 on both sides, and then divide by the negative 5. In here, again, I have a problem that's not going to reverse or reduce nicely, but I do notice that I have two negatives, a negative on the top and on the bottom, and so if I divide a negative by a negative, I'll end up with a positive, so that would be positive 22/5. It doesn't go in again evenly, so it's okay to be left as a fraction. If you have any questions, just email me and let me know.